It's Mrs. Moret here with help on today's assignment from Lesson 17. So Lesson 17 was all about using a process called completing the square to solve quadratic equations. And in completing the square with the problems we did today, sometimes we had solutions that involved imaginary numbers. And so we call those complex solutions rather than real solutions. And sometimes the solutions were real. So let's get started. I actually am going to use a notebook because there just isn't enough room to solve all of these on this paper. So for number 1, problem A, I have x squared plus 0.5x minus 14 equals 0. X squared plus 0.5x minus 14 equals 0. And I want to know what number should be here so that I can complete the square and then use a square root to solve. So to figure out the number that should be here, we've been using the little boxes. And our x squared term goes here. We split the middle term in half, so 0.25x, 0.25x. Oops. And then once we line the sides of the box with these factors, then we end up multiplying these two together to get our C term, the last value, and it's 0.0625. All right, so this minus 14 needs to equal 0.0625. So in order to do that, I'm going to add 14.0625 to both sides of the equation. Okay, so now I have x squared plus 0.5x plus 0.0625 equals 14.0625. Okay, so since this is now a trinomial square and I know it factors as x plus 0.25 squared, then I can use square roots to solve. Okay, so when I square root this side, I get x plus 0.25, and then that's going to equal the positive and negative square root of 14.0625. Okay, and the square root of 14.0625 is actually 3.75, so that's great. So x is plus 0.25 equals positive and negative 3.75. And so the last thing that we need to do is subtract the 0.25 . So we have two solutions for x, the positive 3.75 minus 0.25, and that's 3.5, and the negative 3.75 minus 0.25, and that is equal to -4. So the two solutions are 3.5 or -4. All right, so for B, x squared plus 12x plus 36 equals 0. So I want to do my little factor box and see how to complete the square here. And so I'm going to put my x squared here, break apart 12x into 6x and 6x. Line the factor box, and so what I want to have in the last spot is a 36. And hey, look at that. It's already 36, so I don't have to add anything this time. I'm now going to write it in factored form. X plus 6 squared is equal to 0, which means x plus 6 equals the positive negative square root of 0, which is just 0. So this is only going to have one solution, which we find by subtracting the 6. X equals negative 6. Okay, and problem C. X squared minus 3x plus 8 equals 0. And so, again, the factor box, x squared goes here. Break apart the negative 3x exactly in half. Negative 1.5x in each of those spots. And then negative 1.5 times negative 1.5 is equal to 2.25. So in order for this to be 2.25, I actually have to subtract a number from both sides. I need this to be smaller. I need it to be smaller by 5.75. I'm going to subtract 5.75 from both sides of the equation. And so I have x squared minus 3x plus 2.25, that's the total I get here, equals negative 5.75. And I'm ready to write it in factored form, and all I have to do is look over here. I already have it factored. It's x minus 1.5 squared, and that's equal to the negative 5.75. So this time, when we square root to solve, we can tell, oh, we're going to have some imaginary roots here, some complex numbers. So take off the, when we square root this, we just get x minus 1.5, and then plus or minus square root of negative 5.75. And so we kind of have two options. I could add the 1.5 here, and I get x equals 1.5 plus or minus I root 5.75. Or I could, estimate the square root of 5.75. It's about 2.4. So the other option is about 1.5 plus or minus 2.4 I. Okay, so that's just making an estimate for the square root of 5.75. And then finally, problem C, I can do on the paper because actually, sorry, it's problem D. I can just do right on the worksheet page because it's a simple square root problem. So we're going to solve for x squared, solve for x by subtracting the 4. And so we get x squared equals negative 4. And so x is the positive negative square root of negative 4, which means positive or negative 2i. Okay, on number 2, the rest of the problems aren't nearly as long. On number 2, which describes the solutions to the equation. So either real or non-real and how many. So we're going to subtract 7 here. So we get x squared equals negative 7, which means then when we solve, there's going to be 2 roots or 2 solutions, and they are going to be non-real. Okay, so looks like that would be answer choice D. Number 3, explain how you know that the square root of 3x plus 2 equals negative 16 has no solutions. Well, this is asking for the positive root, and this is a negative number. They can't equal each other. So that's how I know, because this is a positive value and this is a negative value. Okay, moving on. Number 4 has 3 functions graphed. And then your job is to look at equations using those functions and determining how many solutions and whether they're real or non-real. Okay, so for number 1, for letter A, that uses this graph, and so does D. Okay, and so I'll do those two first. So when does the function equal 0? It equals 0 in 2 places, and those are real. So that'd be 2 real. And then for D, equaling negative 2, looks like that just happens at that one spot, and that's real as well. It's the vertex. Okay. And then the graph down at the bottom, this one here, that function is in question B and question F. All right, so for question B, when does it equal 0? And so it doesn't equal 0 on the real coordinate plane. So those are going to be non-real, and non-real solutions always come in pairs of 2. The plus or minus part of what we do to square root and solve. So that would be 2 and non-real. And then for F, when does the function equal 2? That's happening here, and there's 2 places, and they're real. So 2 real. All right, and then the last graph is used on C and E. So for C, we're looking at when does it equal 0? And I see that happens here and here in 2 real solutions. And then for E, when does it equal 6? It does not equal 6 on the real plane. See, it's below. And so those are going to be 2 non-real solutions. Okay, just a couple more problems and we're almost done, but let me show you all of those at one time. So there you go. All right, so we're going to do a little bit of practice here with some multiplication. Now, we didn't cover this specifically, but I think that you could still do this. So let's look at, we've used multiplication and like a box for multiplication of binomials before. So let's just go ahead and do that. And so we have 5 times 5 goes here, that's 25. And then 5 times negative 5i would be negative 25i. And then same here. And then negative 5i times negative 5i, that's 25i squared. All right. Now, one of the things that you have learned is that I squared is equal to negative 1. So this term here actually equals negative 25. So when we look at everything inside this box together, we have 25 minus 25i minus 25i, and then minus 25. So see how I start with 25 and end with minus 25? Those add up to 0. So I'm just going to cross them out. And then here we have negative 50i. So my answer is this: 5 minus 5i squared, what it was asking us to do, equals negative 50i. So the second part, where we're going to raise the same expression to the fourth, what I'm going to do is make a statement here. I think it's the same thing as squaring this, right? Because if this is squared, then to the fourth would just be like square it again. So it's going to be equal to the 5 minus 5i squared, but then squared again. So we kind of covered that in the last unit on the exponents. So since I know the answer to the inside of this is negative 50i, all I have to do is square that. Okay, so negative 50i squared is going to be equal to 2500 I squared. And since I squared is equal to negative 1, it's negative 2500. Final answer. Okay, and then finally here, we want to know if we made this trinomial square, then what is the value of n right there to make it true? Okay, so let's think about, how do we make trinomial squares? Well, we take what we have so far, and I take the 11x and break it apart, right? And that's how the 121 fourths got there. So look at this. So 11 halves times 11 halves is equal to 121 fourths, which means that this factors as x plus 11 halves times x plus 11 halves, or x plus 11 halves squared. So the number that needs to go here is 11 halves. So answer choice B. And that is the end of your assignment. So I hope that you found this video helpful.